All right, so today we're diving into AI megaclusters, and we're going to be using some insights from a recent conversation on the Lex Fridman podcast. It was between Dylan Patel from SemiAnalysis and Nathan Lambert from the Allen Institute for AI. Basically, we're trying to unpack the incredible scale and the power demands of these things, these AI megaclusters popping up everywhere. And did you know that data center power consumption in the U.S. could hit like 10% by the end of the decade? Fueled largely by AI. That's a huge jump from the current 2 to 3%. So, I don't know, what do you think? Does that sound crazy high, or is that just the beginning?
Yeah, I mean, it really highlights the exponential growth we're seeing in AI models, right? Like, think about it. Just a few years ago, running a model like AlexNet on a few GPUs was a big deal. Now we're talking about GPT-4, a model so complex that it required 20,000 A100 GPUs for training.
Whoa, 20,000 GPUs for one model. That's just mind-boggling to me. So for those of us who aren't like knee-deep in AI jargon every day, what exactly is a GPU and like why are so many needed?
Well, a GPU, or graphics processing unit, was originally designed to quickly manipulate and change memory, to accelerate the creation of images. But it turns out they're also incredibly efficient for the complex mathematical calculations that are used in AI. Essentially, the more powerful and complex the AI model, the more GPUs you need to train and run it.
Okay, so in the case of GPT-4, 20,000 of these power-hungry GPUs, we're crunching numbers nonstop. How much energy are we talking about here?
Well, each A100 GPU uses about 400 watts. But when you add in like the entire server infrastructure, you're looking at an energy consumption of roughly 15 to 20 megawatts. And remember, that's just for one model, and those A100s are being replaced by even more powerful H100 GPUs, which consume around 700 watts each, factoring in the associated components. Each unit can use up to 1,400 watts.
Oh, so it sounds like we're entering this era of mega clusters. Just how massive are these things?
Oh, they're truly immense. OpenAI and Microsoft have this massive operation in Arizona with a network of connected data centers housing an incredible 100,000 GPUs.
100,000. It's like a small city, powered entirely by GPUs. And Meta is not far behind, are they?
Absolutely not. Meta is rapidly scaling up, expanding from 16,000 to a staggering 128,000 GPUs within their existing data center network.
Wow, so bigger definitely seems to be better. In a world of AI, where does Elon Musk fit into all of this mega cluster landscape?
Even though XAI started a little bit late in the game, Elon Musk isn't one to be outdone. They've built the world's largest cluster in Memphis, Tennessee. This behemoth packed with 200,000 GPUs.
200,000 GPUs. That's just incredible. I mean, what did it take to build something on that scale?
It was a massive undertaking. They repurposed an old factory and significantly upgraded the substation to handle those intense power needs, and even tapped directly into the natural gas line to power this beast.
Tapping into the natural gas line. That really highlights the lengths these companies are going to just to power these AI megaclusters. And with OpenAI's planned Stargate data center in Texas, requiring like a mind-blowing 2.2 gigawatts of power input, the demand is only going to increase. What about Meta? Are they taking a different approach?
Meta is actually building 2 large natural gas plants alongside a new data center in Louisiana.
So they're becoming their own power supplier. What about the environmental impact of all of this?
It's definitely a concern. Amazon, Google, and XAI are all developing multi-gigawatt data centers. This puts a huge strain on the power grid. In some areas of the U.S., it's actually more expensive to transmit power than to generate it.
That's insane. So like building new power plants can't keep up with this demand from these data centers. So what are these companies doing to address this issue?
Well, many are turning to natural gas plants as like a faster solution. Despite the environmental impact, there's a lot of hope pinned on renewable energy sources, potentially supplemented by batteries and some natural gas. But implementation is lagging behind the rapidly growing demand.
So is renewable energy a realistic solution here? Meta, at least, has made some public sustainability pledges.
While they have made those pledges, it's unclear whether they'll be able to fully achieve them. And despite the impressive technology, even Elon Musk's innovative Memphis facility relies on non-renewable power sources.
It seems like this push for sustainability is kind of getting lost in the scramble for more power. But tell me, are there any signs of ingenuity, any bright spots in this whole power struggle?
There are. These data center teams are constantly innovating to overcome challenges, like finding ways to manage the power spikes that happen during model training.
What do you mean?
Well, training these massive AI models requires immense computational power, which can lead to sudden surges in energy demand. Imagine turning on every appliance in your house simultaneously. Meta has actually developed a clever solution to this by adding an operator in their machine learning framework, PyTorch.
What does this operator do?
It prevents power spikes by making the GPUs compute fake numbers during weight exchange, maintaining a steady power consumption, and avoiding those disruptive surges.
That's pretty ingenious. What about Elon Musk? I imagine he has some innovative solutions up his sleeve as well.
He does. Elon Musk utilizes Tesla Megapacks, these giant batteries that store energy, and can be deployed to smooth out those power fluctuations.
Okay, so we've talked about these power demands. But how do they handle the massive amount of heat generated by these thousands of GPUs?
That's another huge challenge. Data centers have traditionally relied on air cooling, but as GPUs demand more power, water cooling has become increasingly important.
So it's like switching from a fan to a water-cooled system in a gaming PC, but on an epic scale.
Exactly. Google has been water cooling their TPUs for years. Elon's Memphis data center is pioneering water cooling for current generation GPUs on a massive scale.
Current generation GPUs. So they're the first to do this on such a large scale.
They are. It's quite a feat of engineering. They're using 90 external water chillers to keep those chips running smoothly.
90 water chillers. That's a powerful image. So this has been kind of a whirlwind tour of AI mega clusters. And I think we've covered a lot of ground already. Maybe this is a good point to pause and pick things up in part 2.
Sounds good to me. I'm sure our listener has a lot to digest already. Water cooling is more than just keeping things from overheating. It also allows for higher speed connectivity between the chips.
So it's not just about preventing meltdowns. There are performance benefits too.
Exactly. Water cooling is more efficient, allowing the chips to run faster and communicate with each other more quickly. And this is crucial for training those massive AI models we were just talking about.
Okay, this is starting to paint a pretty wild picture. We've got these gigantic data centers consuming insane amounts of power and pushing the limits of cooling technology. Where does this all lead? What's the end game here?
That's the million-dollar question, isn't it? On one hand, we have this incredible progress in AI models that can generate text, translate languages, write code, even create art, but it comes at a steep cost, both financially and environmentally.
So are we reaching a point where the energy cost becomes too high, where the environmental impact outweighs the potential benefits of AI?
It's a valid concern, and it's something we need to grapple with as a society. Can we sustain this level of energy consumption as AI continues to advance, or will we hit a wall?
It's a tough question, but I have to believe that human ingenuity will find a way. Maybe we'll see breakthroughs in renewable energy or energy storage, or perhaps we'll find ways to make AI models themselves more energy efficient.
I hope you're right. There are certainly brilliant minds working on these problems, but it's going to take a concerted effort from governments, industry, and researchers to find solutions that are both sustainable and scalable.
We briefly touched on power purchasing agreements, or PPAs, earlier. Can you explain what those are and how they fit into this picture?
A PPA is basically a long-term contract between a renewable energy provider and a buyer, in this case, a data center company. The buyer agrees to purchase a certain amount of electricity from the provider, typically at a fixed price for a set period of time.
So it's a way for data centers to secure renewable energy for their operations.
Exactly, and it can be a win-win situation. The data center gets a guaranteed source of clean energy, and the renewable energy provider gets a stable revenue stream, which helps them finance new projects.
So why aren't all data centers using PPAs? It seems like the perfect solution.
It's not always that straightforward. There are complexities involved. For example, the availability of renewable energy can vary depending on the location and the time of year, and transmitting that energy from the source to the data center can be challenging and expensive.
So it's not a one-size-fits-all solution.
Not at all. And there are also criticisms about how some companies are using PPAs.
How so?
Well, there's concern that some companies are using PPAs more for marketing purposes than for genuine sustainability efforts. They might sign a PPA for a small portion of their energy needs while still relying heavily on fossil fuels.
This is a bit of a greenwashing tactic.
That's the worry. At least in some cases, it's important to scrutinize these agreements and make sure they're truly contributing to a cleaner energy future.
This is fascinating stuff. It really highlights the complexities of this whole AI power puzzle. We've talked about the scale of these data centers, the power demands, the cooling challenges, the sustainability struggles. Is there anything else our listeners should know about the infrastructure behind these AI giants?
One thing that often gets overlooked is the importance of networking. These data centers are essentially massive interconnected networks of computers, and the speed and efficiency of communication between those computers is crucial for training and running AI models.
So it's not just about having enough computing power, it's also about how well those computers can talk to each other.
Precisely, think of it like a symphony orchestra. You can have the most talented musicians in the world, but if they can't hear each other and play in sync, the music will fall apart.
That's a great analogy. So
Right.
what are these companies doing to ensure seamless communication within these massive data centers?
They're investing heavily in high-speed networking technologies. For example, many data centers are using fiber optic cables to connect the computers. These cables can transmit data at incredibly high speeds with minimal loss of signal.
I've heard of fiber optic cables for internet connections. Are they the same thing?
Yes, the same principle applies. Fiber optic cables use pulses of light to transmit data rather than electrical signals. This allows for much faster data transfer rates.
That makes sense. So these fiber optic networks are like the nervous system of the data center, connecting all the different components and enabling them to work together.
Exactly. And as AI models become more complex and data intensive, the demands on these networks will only grow.
It seems like every aspect of these data centers is being pushed to the limit.
And that's the nature of innovation. We're constantly pushing the boundaries of what's possible, but it's important to remember that progress comes at a cost.
And that cost isn't just financial, it's environmental and potentially societal as well.
Absolutely. We need to be mindful of the trade-offs and make sure we're making wise choices about how we develop and deploy these powerful technologies.
This has been a truly eye-opening deep dive into the world of AI megaclusters. So far, we've covered a lot of ground, from the sheer scale of these data centers to the challenges of power consumption, cooling, sustainability, and networking. I think we've given our listener plenty to think about.
It's a fascinating and rapidly evolving field, and I'm sure there will be plenty more innovations and challenges to come.
No doubt about it.
Yeah.
This is a story that's just getting started. We'll have to keep our eyes peeled and see what the future holds.